Hello all. We continue again with factorization of polynomials. Let us deal with the question. Show that 25x raised to 5 minus 9x raised to 4 minus 3x square minus 12 is irreducible over Q. So let us use our Eisenstein's criterion. What this criterion tells us, you can see once again, you have to search such prime P. P belonging to Z be a prime. This is your polynomial, general polynomial in Z of x. Now, this an is not divisible by P, but all other coefficients, they are all divisible by P. And one more thing, that the constant term is not divisible by P square. If this happens, then directly we can decide that f of x is irreducible over Q. Let me repeat. The leading coefficient an should not be divisible by that prime P. Rest all coefficients must be divisible by P, and at the same time, the constant term must not be divisible by P square. If it is so, then you can directly decide by Eisenstein's criterion that f of x is irreducible over Q. So let us use this fact over here. You can see this is 25, this is 9, this is 3, and this is 12. So what is the common prime factor for all the rest? You cannot take 5 because 5 divides 25. What else you have? So 12 is there, and the factors of 12 are 2 and 3 only. Prime factors of 12, they are 2 and 3 only. And what we observe? 3 divides all the remaining. So this is what we have written here. 3 does not divide the leading coefficient, but 3 divides the rest all. And if I take 3 square, 9 does not divide 12. So Eisenstein's criterion fits over here, and we can directly decide that the polynomial is irreducible over Q. So I suppose you followed me. This directly gives us, once again let me visit it. The divisors, prime divisors of 12 we search, they are 2 and 3 only, but 2 doesn't divide those, so we won't deal with 2. Let us go with 3. 3 divides 9, 3 divides 3, 3 divides 12, but 3 square does not divide 12, and that is why by this criterion we say that the polynomial is irreducible. So I suppose you have got this point. Is it okay? Did you get the answer? Okay. Only one response. All right. All right. I continue. I would like to go with the next example. Show that x raised to 4 plus 4 can be factored into linear factors of z5 of x. X raised to 4 plus 4 can be factored into linear factors of z5 of x. So some part I have solved over here. So let us discuss. You know better that z5 has these 5 elements 0, 1, 2, 3, and 4. And let us see what happens if I put 1 in place of x. I got 1 plus 4. That is 0 in z5. Means what? X minus 1 must be a factor of f of x. That is our factor theorem. So I started dividing by x minus 1. I think you can directly do so. X cube into x, you got this particular, you subtracted, x raised to 4 gets cancelled, you are left with x cube plus 4. Again you have x square as the quotient, you got x cube minus x square, subtracted, getting back x square plus 4. Again the quotient is x, so you got x square plus 4 minus x square minus x, so x square is cancelled, but this x plus 4 is there. Now x plus 4 divided by x minus 1, you know the quotient will be 1. So this is x minus 1, but when you subtract, you get x is getting cancelled and you get 4 plus 1, that is 5. But 5 means 0 in Z5. That is why remainder is 0. Means this division is a complete division with remainder 0. So what you can say? This f of x raised to 4 plus 4, you can write as x minus 1 times the quotient. I suppose you are following me. Got the division? Okay. Now, what you'll do is, you'll continue with this x cube plus x square plus x plus 1. You have a limited set, only 5 elements are there. A 0 will not do, 1 will not do. As you are watching, 1 plus 1 plus 1 plus 1, it generates only 4. If you go for 2 cube in Z5, 2 cube is what? Actually 8, but it becomes 3 in Z5. I suppose you are following me. If not, I would like to go here. So you have x cube plus x square plus x plus 1. Let us call this as p of x for the time being. I hope you can do so. And now you put the value of x as 2, as I said just now. I'm calculating p of 2. This is actually my rough work. So 2 cube plus 2 square plus 2 plus 1. So immediately, can anybody tell me what is the answer? 2 cube for me is not 8, it is 3. 2 square is 4, no doubt. And you have plus 2 plus 1. So I may call it as 3. So what do you have? 6 plus 4 is 10. 10 is a 0. Can you say it is a 0? So 10 is nothing but a 0 for us. So ultimately, you are going to get x equal to 2 as a factor. Is it, just a minute, x cube plus x square plus x plus 1. Yes, 2 cube. 2 cube is 8. 8 divided by 5. 3. 2 square is 4. 2 plus 1. Okay. So I got 3 plus 4 plus 3. So I got a 0. Yes. So if I start with x minus 2, I should be able to complete the division. I hope all of you are watching here. This was x cube plus x square plus x plus 1. Okay. And you said that at 2 I'm getting a 0. So x minus 2 must be certainly a factor of this. So let us divide. I hope you will help me. So this is x square. Quotient will be x square, xa. I got x cube. Then I have minus 2x square. And I'm subtracting. So I change the signs. This will be minus, this will be plus. So what do you get in hand? 3x square. Am I right? Plus x plus 1. What is the quotient now? I want 3x square. So I need 3x. I need 3x. So what will happen? 3x into 3x. Single x. It gives me 3x square minus 6x. Okay. At this moment, let me write minus 6x. And we are subtracting. So what happens? This goes off. And this becomes 7x. And 7x means I'm having 2x plus 1. Hope you agree. Then I have to divide by plus 2. If I divide by plus 2, what do I get in hand? Yes, come up. 2x minus 4. Yes, and I'm subtracting. So what is the answer? Signs I have to change. This will be plus 5 and plus 5 is nothing but a 0.
Zero.
So what is the factorization I got? X square plus 3x plus 2. X square plus 3x plus 2 and multiplied by x minus 2 multiplied by x minus 2. This is the factorization of p of x. So this way you can continue. What I did was I put x equal to 2 in the polynomial. I got a 0, and because I got a 0, I said that x minus 2 must be factor by factor theorem. So I divided the actual polynomial by this factor, and I got some quotient, and I checked whether my remainder comes out to be 0 or not. Yes, the remainder is 0, so I got this factorization. Followed me? Okay, okay. Then, so this way, so am I wrong anywhere here? Please check the actually correctness of this particular, whatever I did. Okay, you have this document with you. So are my factors correctly written? So please check it. Okay, so I started with x equal to 3 and I got a 0. So the factors actually ultimately I should get the same. X minus 1, there I'm getting x minus 2, and nowhere I find x minus 2 here. So please check my answer. Okay, and convey me. I hope you will do so. Okay, here we got the factorization as x minus 2. So ultimately what we are reaching to, our original f of x was given to us. There we actually divided by x minus 1 in the initial stage. Later I divided by x minus 2, and I'm just getting x square plus 3x plus 2, which we can actually factorize as x plus 2 into x plus 1. Can I? Can I? X plus 2 into x plus 1. You can do so, because if you put x equal to minus 2, minus 2 square becomes, this is actually rough work I'm doing, minus 2 square, come on, plus 4. Then minus 2 threes are, it will give me minus 6. And I'm having plus 2, so this goes to 0. I hope you all agree. So this particular polynomial will have x plus 2 as a factor. What I did was I put x equal to minus 2. At the same time, I can try with x equal to minus 1 also. If I put x equal to minus 1 here, so what it will generate? Minus 1 square is plus 1. Minus 1 threes are, I'll get minus 3, and plus 2 will generate 0. So I feel this is the correct answer. Sure?
Ma'am, we have to apply it for every factors, na?
Yeah. They have asked us to actually, let me show you the question. Yeah. So what question says? Show that this can be factored into linear factors and find the factorization. So we have to factorize it. Sure. So where I was wrong, let me check it. I said x equal to 3. So 3 cube is 27. Yes. 3 square is 9 plus 3 plus 1. So 27 plus 3, I got 30, plus this 10. Again, I got a 0. Twice 0 is a 0. So I think I'm right over here. X minus 3 has to be a factor. Have we got it anywhere? No. So two different kinds of factorizations we have got. Okay. So once you can check it, let us once again try over here. See, I got 3. Let me put it here. 3 raised to 4 is what? 81 plus 4. How much? 85. And 85 in Z5. 85 is
Zero.
divisible by 5, so 0. So I'm right here also. That answer is also correct and this answer is also correct. If I put minus 3, still I'm getting the same. Minus 3 raised to 4 gives me 81 plus 485 is 0. So this is correct and this answer is also correct. Okay. So that way you can check it. So this is the possible factorization of f of x. Got it? But you have to justify your answer by saying this. You'll show that it gives you a 0. If you put the value of x in f, you should get like this. F of 1 is 0. Here I have shown f of 3 is 0. This was f of 3. We have shown that it comes out to be 0. So same way you can show that if f of 3 is 0 means x minus 3 is a factor. And continue division. By continuing division, you'll come to your answer. Also, what I have done here, I have gone with minus 3 also. If I go with minus 3, this will be x plus minus 3. So I got two factors, x plus 3 also and x minus 3 also. So suppose you got me. Sure? Okay. All right. Now let us continue with our next example. Next example is show that x cube plus 2x square plus 2x plus 1 can be factored into linear factors in Z7 of x and find the factorization. So basically I must know what is Z7, what are the members of Z7. So they are 0 to 6. Now you can pick up any of these and just continue with f. If you are getting 0 at all, that means x minus that number is a factor. So we started with 2. Actually 0 will not work. 1 will not work because 1 plus 2 plus 2 plus 1. It produces 6, not 0. So we continued with 2. 2 cube is 8. 8 means 1 in Z7. Here again I'm getting 2 cube kind of thing. It is again 1. 2 twos are 4 and plus 1. So you got this to be 0. I suppose you followed me. So x minus 2 is a factor. So divide by x minus 2. Okay. So you are watching x square exa x cube minus 2x square. Subtraction gives you 4x square plus 2x plus 1 just carried as it is. Then you want 4x square. So you multiplied by 4x here. Quotient is 4x. So 4x square minus 12x. 4x square. One minute. I said 4x square minus 8x. Minus 8 meaning I should get it to be minus 1x. Is it so?
Yes, ma'am.
Just a minute, let me change this. Okay, I had minus 8. Minus 8 is congruent to what? Modulo 7. So if I take minus 1, what will happen? Minus 8 minus minus 1. So I have minus 8 plus 1. Is it so? So I got minus 7, which is divisible by 7. I suppose you are following. If not, continue with minus 8 and later on you can do it. So if I continue with minus 8, what it will give me? 4x square minus 8x. What will be the sum? You need to change the signs. So this is 8 plus 2. 8 plus 2, 10. You are in Z7. So it comes to be 3. Is it so? Reminder, when divided by 7 produces 3. So we are right. Then 3x plus 1. You need 3 over here. So 3x minus 6. And again if you subtract, this is 6 plus 1, 0. So you got a 0. So it's a factor. And here directly you can watch. It is x plus 3 into x plus 1 as usual. So you can continue. X plus 1 is a factor and you got the factorization as this one. Followed? All right. All right. Now, I would like to continue with this particular. There is a kind of question. Demonstrate that x cube plus 3x square minus 8 is irreducible over q. X cube plus 3x square minus 8 is irreducible over q. So, how would you go? So, I've got this kind of document for you. Have to write the, so I'll share this to you. This question they have solved. Demonstrate this is irreducible over q. So, what they're saying, f of x has a 0 in q, then you can once again see, yeah, if f of x equal to x cube plus 3x square minus 8 has a 0 in q, then it has a 0 m in z which divides minus 8. Okay, constant term must be divisible by that. So we test the divisors of minus 8. What are the divisors of minus 8? Minus 8 itself, minus 4, minus 2, minus 1, 1, 2, 3 and 1, 2, 4 and 8. And they have calculated f of x. So nowhere they are getting a 0. You can watch. Nowhere you get a 0. So there is no 0 in z. And so there is no 0 in q also. So by factor theorem, f of x has no linear factor. So f of x is irreducible over q. Followed my point? So what we need to do is just check with the x's, the divisors of the constant term. That helps you. Followed me or should I repeat? Followed?
Ma'am, please repeat it once.
Yeah, I would like to. See, constant term here is minus 8. So we always try with the divisors of constant term. So we tried with the divisors of minus 8 itself, minus 4, minus 2, minus 1, 1, 2, 4 and 8. All divisors, they have tabulated it. Okay, this is a ready-made answer I got. So I have given it to you. And what you are watching, if I take minus 8, then minus 8 cube plus 3x square minus 8, we are in q. So we are trying in integers. So whenever we discuss about q, we always discuss about z. This you know very well. So what we are doing is we are trying with those divisors in this f of x. So putting x equal to minus 8, we get this answer as minus 328. It is not a 0. And if it is not a 0, then obviously minus 8 cannot be the root. I mean minus 8 cannot be the 0. Go with minus 4. Minus 4 cube. What is it? Minus 64. Then minus 4 square. 16 threes are 48.
40.
Yes. And minus 8. Does it create a 0 anyway?
No.
No, this is not 0. So we are searching for a 0. Do we really get a 0 with the divisors of minus 8? That we are trying. So it is not 0 anywhere. This you need to show because you are getting 5 marks for that. So you have to show with every x, every divisor of that particular constant term. Okay. So this was a demo kind of answer I have shown to you. Satisfied with the?
What is the value of constant term?
Repeat your question, please.
Ma'am, only with the divisor of
Yeah, only by constant term. Why? So here we have dealt with it. You know this better. This is the theorem that we apply always. है ना? Corollary. If f of x is in z of x with a naught not 0, constant term is non-zero, And if f of x has a 0 in a q, then it has a 0 m in z, and m must divide a naught. Is it so?
Yes, ma'am.
This corollary is useful for us. So same we have used. They're using the same letter here, m belonging to z. Okay. So this was a kind of ready-made document with me. I would like to share it to you. Hmm? The pattern, how to write the answer, that is important. Actually, it's a part of some book, I think so. It was on available on internet, so I have copied it down for you. Sure.
Yes, ma'am.
Okay, then I would like to go next for just a minute. Yeah, this question. So demonstrate this is irreducible over Q. Here again, what you watch, this is x raised to 4 minus 22 x square plus 1. And we want to show that it is irreducible over Q. So how would you go? So this being 1. The prime divisors, there are no prime divisors, isn't it? The divisors of 1 are only plus 1 and minus 1 in Z. So with plus 1 also this is not giving 0. With minus 1 also it is not giving 0. We always concentrate to the divisors of the constant term. Followed?
Yes, ma'am.
Okay. So this is your job to write these answers in your notebook. Now, I would like to proceed with this particular question. I hope you can read it. Find all generators of the cyclic multiplicative group of units of the given finite field. I repeat, find all generators of the cyclic multiplicative group of units of the given finite field. What field is given to me? Z5 is given to me. So I would like to continue with this particular Z5.